All right, mathletes, here we're starting our new and final unit on trigonometry. We're going to look at 9.1, the Pythagorean Theorem. Hopefully you've had exposure with this before, but we should note that our Pythagorean Theorem is a squared plus b squared equals c squared, where c is our hypotenuse of a right triangle. Okay, so if we do c squared, this area in the blue on the right side is c squared, because we have right angles here, and each side length is c. Okay, and that c squared is going to be equal to the sum of the two legs squared. So if you look at over here on this triangle in the green, okay, that this is representing a squared, and this is representing b squared. Okay, and that by rearranging these triangles that have a by b legs and a c as a hypotenuse, and we go back and forth, we can see the area in the green is equivalent. So we can see that that area can either be represented by c squared on the right or a squared plus b squared on the left. So that's one way of looking at the proof. Okay, so there's our Pythagorean theorem. Some common things that we want to make sure we notice here is that our c is always opposite our right triangle. And as you're setting that up in your equation, that hypotenuse must be the sole term by itself on the side of the equation sign. As far as your legs go, your a squared and your b squared, it's kind of arbitrary which one's a and which one's b, but we just need to make sure those are the legs of the triangles and not the hypotenuse. Okay, so numbers that are whole numbers that meet the Pythagorean theorem, okay, we call these Pythagorean triples. Okay, so some of the most common ones that are useful to commit to memory is our common 3, 4, 5, our 5, 12, 13, 8, 15, 17, 7, 24, and 25. So these all satisfy the Pythagorean theorem. And I know that because the hypotenuse needs to be the same, the longest leg, I know that this value here, the longest value, would be my c. So that's my hypotenuse. Okay, so always assume that that longest side is your c. And then if we take multiples of those and just scale those up, we can see that if we double them, we get another set of Pythagorean triples. If we triple them, and this is just our general formula saying that we can scale those right triangles up or down, and we still are going to have Pythagorean triples. Okay, there are a lot of other Pythagorean triples, but these are the most common ones that we can see. Okay, so if I want to use the Pythagorean theorem, I can use that to find our hypotenuse. Okay, well, our hypotenuse needs to be the expression that's by itself, so that's x squared, is equal to the sum of the other two legs, so 5 squared plus 12 squared. Okay, so if I notice this out, I see that this is a Pythagorean triple, so I get 25 plus 144 equals x squared. X squared equals 169. So if I take the square root of both sides, because I have x squared, I'm going to get my resulting x equals square root of 169 is 13. And we know that 5, 12, and 13 are Pythagorean triples. Okay. So for the next one, okay, I can solve for x. So now notice that x is a leg, so that needs to be with my 7 squared. And that my hypotenuse opposite my right angle is a term by itself squared. Okay, so now if I square both of these, I get 49 plus x squared equals 196. Okay, I subtract 49 from both sides. Here, x squared is equal to 147. So then if I take the square root of both sides, I'm going to get x is approximately 12.12. Okay, that's not an integer. That's not a whole number. Okay, so it does not form a Pythagorean triple. So 7, 12.12, and 14 are not a triple because they're not whole numbers. Okay, it is a right triangle, but we'd get a number that's irrational here. Okay, so it's not a Pythagorean triple. So word problems. So here we're looking at two skyscrapers. They're supported with a skywalk across. We got to add these support beams to make sure that skywalk is supported in the middle. So what I notice here, I'm going to outline in green that we have congruent triangles. Okay, by side angle side. So I just need to find that 1x for that support beam. Okay, so notice that x is opposite my right angle. So this is my C value of my Pythagorean theorem. So I need to make sure the other two sides are squared and summed to equal my x squared. So I get 47 plus 57, which is a leg squared, plus 23.36 squared equals x squared. So if I square these out, I get 545.69 plus 23.36 squared is, oh, I have these wrong here. Hold on, let me fix that. 47.57 squared is 2,262.90 approximately, and 23.36 squared is 545.69 equals x squared. Adding those together, we get 2,808.59 equals x squared. And again, to undo my square root, I need to make sure I take the square root of both sides. So square root of 2,808.49 is approximately 53 meters. Okay. So the other thing we want to be aware of is we can use the converse of the Pythagorean theorem to say, hey, if we have three numbers that satisfy this theorem, then we can make the conclusion that it's a right triangle. Okay, so early surveyors used this as a way to construct right angles. So they knew that we had triangles of like 3, 4, and 5 that made a Pythagorean triple, but also made a right triangle. So as long as they were able to construct those lengths exactly to be that, they knew between the 3 and the 4 they got a right angle. Okay. So if I want to determine if something is a right triangle, I'm just going to determine if it satisfies the Pythagorean theorem. So the trick is to make sure that you set your C as your longest side, because we know our hypotenuse needs to be our longest side potentially. So as I do the square root of 113 in my calculator, I see that this is about 10.63. So that would be the potential C value. So then I'm going to take my two legs and square them. So 8 squared plus 7 squared. If this equals, so I'm going to put a question mark here. If this equals the square root of 113 squared, then we know it's a right triangle. So as we do this, we get 64 plus 49 equals, well, the square cancels out the square root, so 113. So 64 plus 49 is 113. So this is a right triangle. And I can identify my right angle now as being this angle that would have to be across from my hypotenuse. So on my second example here, if I do 4 square roots of 95, okay, I get about 38.5 0.99. That's our longest side, so this would be potentially our C. Okay, so I'm going to take my other two legs, 36 squared plus 15 squared, the shorter of the three sides, and set it equal to 4 square roots of 95 squared. So I got a squared plus b squared equals c squared. I don't know if they're equal quite yet. Let me put my question mark there. So I am going to get 36 squared is 1,296 plus 15 squared, which is 225. And 4 squared is 16. Square root of the squaring of the square root of 95 is just 95. So I'm squaring the 4 and I'm squaring the square root of 95. So 16 times 95 is 520 or 1,520. And I add up the sum of my other two squares. Okay. Plus 225. Okay, I get 1521. They are not equal, so it's not a right triangle. So our next theorem says, well, if it's not a right triangle, what type of triangle is it? So the Pythagorean Inequalities theorem states these facts. Okay, so if our longest side, our c squared, is less than the other two sides put together, then our triangle must be acute. So I think about this c being less than. So if we make this angle right here smaller, well, if we make that smaller than 90 degrees, which is an acute angle, that's going to truncate our hypotenuse there. So it's going to be smaller than a right triangle. On the other side of the spectrum, okay, if our c squared is larger than what it would be if a right triangle, that means this c angle here got larger because this is a larger length. So this length is larger than it would be for a right triangle. So then we must have an obtuse triangle where c would be our obtuse angle. Okay, so our examples that would look like this. So if we want to show verify the segments can form a triangle, so we remember from our triangle inequalities, we look for our two smallest sides. We add them up. If that is larger than 6.1, sure, it can be a triangle. Okay, so now that we know that it can be a triangle, is the triangle acute, right, or obtuse? So again, I don't know if it's a hypotenuse, but I'm going to look at my largest side, 6.3, and dictate that as my C. So I'm going to do 6.1 squared. And I'm going to leave a box here to decide if I'm going to put an equal to, a less than, or a greater than symbol there to determine my triangle. And then my two smaller lengths squared and summed together. Okay. So as I do that, I get 45.53, and 6.1 squared is 37.21. So because the C, the longest side, is shorter than those two, okay, this must mean that this is an acute triangle that we're dealing with. Okay. Next example here, again, verify that it's a triangle. Look for my two smallest sides, 3 and 4. Is 3 plus 4 greater than 6? Yes, it can be a triangle. Okay, that's our triangle inequality. Now we want to determine what type of triangle it is. So looking at my three sides, 6 is my longest side, so that would have to be my C. So 6 squared. Box, I'm not sure what inequality is here. And then 3 squared plus 4 squared. Okay, well, 3 squared is 9 plus 4 squared is 25. 6 squared is 36. So now I see that 36 is greater than 25, so that hypotenuse is really long. With a longer hypotenuse, it's not technically a hypotenuse, just our longest laid. That's going to force our triangle to be obtuse. Okay, that concludes our notes today. I also attached a YouTube video from TED Talk about the proofs of the Pythagorean theorem. I encourage you guys to watch that. Bring any questions you have to office hours.